We have discussed about the nitration and halogenation of benzene. We will now study about more electrophilic substitutions. So, the third one is sulfonation. Okay. Sulfonation means hydrogen is replaced with SO3H. So, we have benzene, we add fuming sulfuric acid here. What is fuming sulfuric acid? Fuming sulfuric acid means SO3 added to concentrated sulfuric acid. Fuming sulfuric acid gives this. Okay. So, we will study its mechanism. We have SO3. Okay. SO3 is this, and we have sulfuric acid. Okay. Sulfur do not have any lone pair here. One SO bond breaks. There were double bond between sulfur and oxygen, right? So, one double bond breaks and this electron is donated to the hydrogen and this happens. So, now we have this, that is HSO3, and this negative. Okay. Now, one bond has broken, one sulfur oxygen bond has broken and the bonded electrons have been donated to this hydrogen. So, now sulfur develops a positive charge. Now, we have benzene. So, pi bond of benzene will break and it will attack on this electrophile. This is the electrophile here, okay. SO3H plus. This is the electrophile. So, we get SO3H and this carbocation. Now, this carbocation can undergo resonance. Okay. Now, we have this as the nucleophile in this system and we have hydrogen here. So, now HSO4 minus acts as a base and it takes up this hydrogen and the double bond is back again. So, this was the sulfonation of benzene. Okay. Now, next important reaction is Friedel-Crafts alkylation. Friedel-Crafts alkylation. Okay. So, till now we had studied about the reaction of benzene with other groups like nitro, halogens, sulfonation, etc. Now we will study how we can add another carbon with the benzene carbon. Okay. So, there are two methods. One is Friedel-Crafts alkylation and another is Friedel-Crafts acylation. So, the first one we will study is Friedel-Crafts alkylation. So, the statement for this reaction is benzene is treated with an alkyl halide in the presence of anhydrous aluminium chloride and alkyl benzene is formed. Okay. So, when benzene is treated with an alkyl halide in the presence of anhydrous aluminium chloride, and then an alkyl benzene is formed. So, we have alkyl halide and anhydrous ammonium chloride. Okay. So, benzene plus, let's say, methyl chloride CH3Cl, and we have anhydrous aluminium chloride. So, we get this. This is toluene. Okay. So, let's say first the generation of electrophile. We have methyl chloride, we have aluminium chloride. So, the electrophile is generated like this. We have this carbocation, we have AlCl4 minus. Okay. Now, there is benzene. So, pi bond of benzene will take up this methyl cation and it forms the methyl benzene. Okay. And this one will have a positive charge. Now, we have resonance structures. Now, this double bond will come here. The carbocation is formed and these are its resonance structures. Now, in the last step, we have AlCl4 minus here and this takes up the hydrogen and we form this double bond. Okay. So, we get toluene. This is the Friedel-Crafts alkylation. So, if we add ethyl chloride to benzene, in presence of anhydrous aluminium chloride, we will get ethyl benzene. But there is one exception. if we add propyl chloride to benzene, then by this logic we should get propyl benzene like this, right? But this doesn't happen. Instead, what happens? Let's say we have this. Okay. Now we get this electrophile. But this is a primary carbocation, right, which is not stable. Now rearrangement can occur. This is primary carbocation and this carbon has hydrogens. Now one hydrogen will migrate here and a secondary carbocation will be formed. The driving force of this rearrangement is the stability of the carbocation. Okay. Now this is the electrophile for this reaction. Now we have benzene and we have this electrophile. So we get isopropyl benzene. Okay. So this is the electrophile. We do not get N-propyl benzene. So this was Friedel-Crafts alkylation. Now we will study about Friedel-Crafts acylation. Okay. We will read about Friedel-Crafts acylation. So, for Friedel-Crafts alkylation, we were adding alkyl groups to benzene. For acylation, we will add acyl group. What is acyl group? CH3CO. This is the acyl group. Okay. So, for this, we will take benzene. We will have this acyl chloride and we have anhydrous aluminium chloride here and we get this. So, we had the acyl chloride and we had aluminium chloride. So, the bond is formed like this. AlCl4 minus. Okay. So, now we have benzene. So, the electrophilic substitution part occurs. And this is the positive charge. Okay. So, now resonance will also occur. Again one resonance structure. Now there is this hydrogen and we have AlCl4 minus, right? So finally we get this product. Okay, so this is the Friedel-Crafts acylation. Now we have studied about various electrophilic substitution reactions of benzene. Like we have studied nitration, halogenation, sulfonation and Friedel-Crafts alkylation and acylation. All these reactions had produced monosubstituted products. Now if we use excess amount of these electrophiles, we can also obtain more substitution on the benzene ring. For example, so if excess electrophilic reagent is used, then further substitution can occur. Okay, so this is the benzene ring. We have 6 chlorine and we have anhydrous aluminium chloride. This reaction is carried out in cold, dark environment. Okay, in this case we get this, that is chlorine is present in all the 6 carbons of benzene. So this reaction occurs when we have excess electrophilic reagent. So by this we have completed the electrophilic substitution reactions of benzene. In the next lecture we will study about other types of reactions and one other interesting property of benzene. Thank you.